Okay. Welcome and good day, everybody. Today, myself, Ahmad Khairil bin Jabar, and my colleague, Munirah Othman, would like to present a paper titled Assessment on Sustainability of Cocoyam for Heavy Metal Removal in Industrial Wastewater. So, a bit of introduction. So, in some pharmaceutical companies, they produce a high volume of wastewater that is laced with heavy metal elements. So before being released into the sewerage, this wastewater must be treated. If not, the heavy metal will affect all of the life in the streams and in our nature. So conventional treatment methods that exist, they either produce high hazardous byproducts, or they are expensive. So there is a method using Cocoyam to remove heavy metal from wastewater. There are also literatures that have proven that this method can be effective. So our problem statement for this paper, Cocoyam is able to reduce heavy metal in wastewater, but how much is still in the plant? What we mean is how much heavy metal residue is still in the plant. Can the plant be safely used for other purposes after being used for removal of heavy metal? So if we can prove that Cocoyam can be used for other purposes after it has been used for heavy metal removal, then we can say that the method using Cocoyam is a sustainable method, and it's quite a good method if it's like that. So our objective are to conduct lab tests on Cocoyam samples for heavy metal content, and we will determine the sustainability of this method by comparing the results obtained from the tests with established guidelines, mainly provisional tolerable weekly intake or PTWI figures that we obtain from Codex 10. Codex 10 is a standard for heavy metal content in food and agricultural products. This standard was created by the Food and Agricultural Organization of the United Nations. So in this paper, we refer to Codex stand number 193, version 1995. So when we did this paper, that was the older version. If you look at the FAO website now, you will find a newer version of the codex. So the figures that are written in the latest codex is quite different from what we have referred to. So just a heads up there. Alright, so these are some relevant literature reviews. So these are the conventional methods that are being used to remove heavy metal residue from wastewater. So there's precipitation, which is the usage of chemicals to remove the heavy metal traces. So precipitation actually produces a large amount of low density sludge, which we call hydroxide precipitation. And they also produce dihydrogen sulfide fumes, which are also not very friendly to humans. We also have the ion exchange method. This method uses resins to remove or neutralize the heavy metal content, but the resins that are used in this ion exchange method is very costly, and it constantly needs chemical regeneration, which is the process that makes the resin effective for the removal of heavy metals. So this chemical regeneration produces secondary pollution, so it's not that very friendly for the nature. Activated carbon and also carbon nanotubes, the cost is quite high, and it also uses natural resources for carbon, such as coal and also plants that need to be processed. Okay, so there is also the use of bio-waste, shells, algae, fungi to remove heavy metal in wastewater. But so far, these methods using these bioorganisms are at the experimental stage, and also they are limited to the lifespan of the bioorganisms. So they need to be constantly changed and refreshed and replanted. So that has some limits there. Lastly, there's Cocoyam. So previous literature has proven that using Cocoyam can remove heavy metal in wastewater and soil. So we are going to try to see if there are traces of Cocoyam of heavy metal in the Cocoyam, so that we can say that it is truly sustainable. So this is our methodology. Um, our objective is in the blue box there. So we will collect samples from our site. So actually, for this site, we have 5 retention ponds from numbers 1 to 5. The wastewater will first come out into pond 1 and it will trickle down to pond 5. So the cocoyams are planted around pond 1 and pond 3. So there will be 2 sets of samples to be taken. The samples that we took were leaf and stalk samples. When we took the samples, we will send them to the laboratory. The laboratory that we sent them to was the laboratory in University Malaysia Pahang. So there, sample preparation is done, and it has gone through XRF testing methods to determine the heavy metal content inside the samples. So our second objective is in the red box, which is the discussion and comparison of results obtained from objective 1. So for the results of our test and comparison, my colleague Munirah will continue from here.
I will continue the presentation with the result we got from the lab test. This is the result for arsenic level in leaf sample and PTWI limit. The PTWI limit is the limit for person weight 50 kg and the value is 0.15. For pond 1, the result is 0.06 and for pond 3, the result is 0.043. Next result is the lead level in leaf and stalk sample and FAO limits with PTWI. So the PTWI limit is 1.25 and the FAO limit is 0.3. The result for pond 3 is 0.6 and for pond 3 is 0.3 for stock sample, and for leaf sample the result is 0.7 and for pond 3 is 1.7. This is the result for cadmium level in leaf and stock sample and FAO limits with PTWI. The PTWI limit is 0.35 and the FAO limit is 0.1. The stock sample result is 0.0179 for pond 1 and 0.024 for pond 3. And for leaf sample, the result is 0.2 for pond 1 and 0.024 for pond 3. Based on the result we got, so we can conclude that heavy metal element can cause health problem if the minimum safety amount is exceed. Lab testing show that arsenic and mercury are below the safety level of heavy metal content and PTWI. For lead, both sample level exceed the content limit set by the FAO. However, they do not exceed the PTWI except the leaf sample from pond 3, we show a sudden spike in lead content. For cadmium, the stock sample exceeded the content limit, however, it was still below the recommended PTWI level. It can generally be concluded that the stalk and leaf of the cocoyam plant that is used to absorb heavy metal in pharmaceutical wastewater and can be consumed. So as the recommendation, we recommend that the sample must consist of the comb and comet beside leaf and stalk. The number of samples might also be increased by taking samples from all of the cocoyam plant around a pond. So that's all from our team. Thank you.